All right, so linear and angular speed or circular motion may not be new to you. You may have, if you've taken physics, if you've taken physics, then you most likely have done that. I don't know if you're in it right now, if y'all have done it yet. I don't know when you talk about it, but either way, somebody give me a different word for speed. Velocity. Okay, so another word for speed is velocity. Right, and so the difference between linear and angular speed, I have this really bad little like 5-second video that I usually show, and I forgot to pull it up, but it's so bad because it's real dark and need to make my own. So we'll just kind of tell you so you have an idea in your head. So we did a merry-go-round problem yesterday where you were sitting 8 feet from the center, right? So let's say that I'm seated 8 feet from the center of the merry-go-round. You're seated 4 feet from the center of the merry-go-round, okay? So you're closer to the center than I am. When that merry-go-round makes one full revolution, we have both gone 2 pi radians. Make sense? So if it took a minute, we did 2 pi radians in 1 minute. Okay. However, since I am farther away from the center, actually went farther than you did. Does that make sense? Which means if I went farther in the same amount of time, I actually went a lot faster than you did closer to the center, right? So that's it. So we have the same angular speed, but a different linear speed. Make sense? Okay. All right, so just want to make sure you kind of understand the difference between the two if you've never done it before. Okay, so to look at this, arc length can be used to analyze circular motion. Suppose an object moves along a circular path S with a radius R. Okay? Okay, so the rate at which the object moves along the path is called the linear speed, or V for velocity. Okay? Your velocity formula looks like this. Velocity equals S over T, and that is your arc length over time. So this was the rate at which the object moves. This is the rate at which the central angle is changing along the path. That's your angular speed, or this curvy looking W. Anybody know what the curvy looking W is called? It's actually a Greek letter. This is the lowercase omega. So when you write it, it's like a lowercase w, but you kind of make it puffier and it kind of curves in. So omega equals theta over t. So that is the central angle over time. Any questions at all at this point? Linear speed, angular speed. So within these, when you talk about them, we also talk about revolutions, and so we need to know how to use the revolutions. There's nothing about revolutions in these formulas, so we got to understand what this means here. So if we have one revolution, whether it's angular speed or linear speed. So for angular speed, one revolution is 2 pi radians, because that's one time around the circle, right? 2 pi radians is one revolution. Oh, yeah. Doing weird things. Okay, there you go. You're welcome. All right, so then one revolution for linear speed, that would be the distance around the circle. That's your circumference, so that's 2 pi r. And that would be a length, so it would be inches, meters, feet, whatever. And so I'm not going to put the units because it could be anything. So if I want to find theta from that information, theta is going to be the number of revolutions times 2 pi. And hopefully that makes sense. If you go around twice, it's 2 times 2 pi, you've gone around 4 pi radians. That's how you figure out what the angle is. If you've only gone around half, then half times 2 pi is going to give you pi radians. Okay, that's where you're going to get the angles from. Any questions at this point? All right, so we're going to start off super basic with these questions, and then we'll get into the more complicated ones. So a bicycle tire with a radius of 14 inches rotates at a rate of 125 revolutions per minute We're going to find the linear speed of the tire in inches per minute. So we got to make sure that we pay attention to the units that they gave us in the question and the units that we want in the end. So they gave me inches and minutes, and I want it in inches per minute, so I'm good. I'm not going to have to convert anything. So my velocity is equal to S over T. So I first have to find S. S equals r theta. The radius is 14. Theta is, oh, I should have, sorry, I didn't space my stuff out well. Let me erase that. Go down here. So S is equal to r theta. So that's going to be 14 times, and then theta is the number of revolutions, which is 125 times 2 pi. So theta is this 125 times 2 pi. So remember, focusing on number sense on some of this stuff, spending a little time on that because that's important. I want you to not only be able to multiply correctly, but making things a little simpler on your own, okay? Because we shouldn't be using a calculator on this. This would be non-calculator stuff. And so, yeah, I could just straight up multiply all that, but let's think about how we can break things apart. And the better your number sense is, the more you can see that easiest. So I'm going to go ahead and multiply 2 times 125. So I'm going to get 14 times 250. Okay, which that's something I could reasonably multiply, but let's just think about what else I could do. Isn't this the same as 7 times 2 times 250? Like if I break up that 14, even though I'm trying to put stuff together, I'm breaking up the 14. Because now if I do 2 times 250, I'm going to get 7 times 500. And in the grand scheme of things, isn't 7 times 500 way easier than 14 times 250? Because that's 3,500 right there. So you get that S is equal to 3,500 pi inches. Now I'm not finished because I need the velocity, but my velocity is S over T, that is S. So this is 3,500 pi inches. The time, the way you determine the units for your time at the beginning is whatever your revolutions are in. This is revolutions per minute, so this is for 1 minute. So I don't need to convert anything, like that's it. So my answer is that the velocity is 3,500 pi inches per minute. Sorry, my work is all over the place in that box because I didn't space my stuff out well. Any questions at all? Fairly simple? I mean, yeah. Okay. So then let's look at number 2. I want to find the angular speed in radians per minute. All right, so omega is theta over t, right? So theta, it's the number of revolutions, 125 times 2 pi, and that would give me radians, over the minutes, it's revolutions per minute, so this would be 1 minute. So omega equals 250 pi radians per minute. Any questions at all? Got to know what the formulas are, got to know how to get the pieces, but we're about to have to convert these and have to think a little bit more. Okay, number 3. A 16-inch diameter tire on a car is making 500 revolutions per minute. So 16-inch diameter tire, 500 revolutions per minute. I want to find the linear speed. Okay, so remember, linear speed, velocity equals S over T. So I'm going to start with S. S equals r theta. So revolutions, I'm sorry, this is 16-inch diameter, so this is going to make it 8 inches for the radius, right? Do you have to write down 8 inches? No, I would suggest that you do. I do for myself most of the time. If not, I'm going to look back up there and use 16 because, you know, even though I definitely know the difference. So this is going to be 8 times, then your theta is the number of revolutions, 500 times 2 pi. So 2 times 500 is 1,000, so this gives me 8,000 pi, what are inches? That's my arc length. So my velocity is 8,000 pi inches over, and then this was 500 revolutions per minute, so this is for 1 minute. Then I'm going to need to convert. Okay, so a little bit of dimensional analysis. I'm going to give you hints on how to do it. There's different ways to do it, different ways to cancel things out and whether you multiply or not, but just stick with me if you're never really good at it, and we can handle this. I need to change my inches to feet because it says, and into miles because it says miles per hour. But I can first change my inches to feet. So the way I know I make sure I put them in there in the right spots, hang on one second. 8,000 inches, so I want to change that to feet first. So if I have inches up here, I need inches down here that will cancel out, and my feet would go up there. So I know for every 1 foot, there's 12 inches. Then I'm going to cancel my inches out. I now have feet. Got to change my feet to miles. So feet, miles, right? Because the feet need to be down here to cancel out. I know for every 1 mile, there's 5,280 feet. If you don't know that, you need to commit that to memory. That's a life skill. You need to know that. So since I'm looking for miles per hour, here's my miles. I'm going to circle it because, boom, I got my miles. But now I have minutes, and I need it to be hours. So minutes are down here, so they need to be up here so I can cancel them out. And I can change minutes to hours. I know for every 1 hour, there is 60 minutes. So those cancel out, and now I have my miles and my hours. Okay? So here's what I suggest you don't do. I suggest you don't multiply everything you can and then reduce. You can do that, but it's better if it's broken up because we're going to try and reduce anyway. The more broken up it is, the easier it's going to be to reduce. So I'm going to reduce before I do anything else. So I'm going to look at this 12, okay, and I've got, well, I know that 12 goes into 60 5 times, so make that 5. If you don't know that offhand, you can divide by 2 or whatever. I can divide these both by 10 and knock out a 0. So the only number I have left in the denominator is that 528, and the only thing I have left in the numerator is the 800, but it's 800 pi. I'm going to circle my pi so I don't forget about him, okay, because he might get lost in all my stuff. And then I'm going to just start dividing by 2. So this is going to become 400. Half of 528, well, half of 500 is 250. Half of 28 is 14, so that makes this 264. Then I'm going to take half of each. Got 200 and 132. Then I go 100, 66, and get 50. And 33, and then, can I reduce that anymore? I lost something somewhere, didn't I? Oh, no, I didn't. Can I reduce anymore? In the denominator, I only have 3 times 11. I can't divide 50 by 3, and I can't divide 5 by 3 or 11, so I think I'm done. So I'm going to circle what I have, so I don't lose it. I have this 5, because I don't want to forget about him, and I've got this 33. So now I just have to multiply 5 times 50, and I get 250 pi over 33, and that is miles per hour. Okay. Now, when all is said and done, if you want to check yourself on a calculator, make sure you're correct, I'm fine with that. But you have to practice that. And I expect to see the work on Cami. If all you do is set it up and have an answer, clearly you didn't try and reduce anything on your own. Now, do you have to reduce exactly like I do? No. I didn't even reduce this the same way I did last period. Because I know I didn't do 12 into 60. I'm not even sure what I did, but it doesn't matter. Every time I do it, I might reduce it differently. It's whatever you see and whatever makes sense along the way. Okay? Any questions at all? Okie dokie. Let's look at number 4. All right, so we have a circular saw blade. We have a diameter of 9 inches. That means my radius is 4, oh, no, it's not. It's 9 over 2 is what I was trying to write. Come on. Okay, let me just do this. Diameter of 9 inches means my radius is 9/2. Rotates at 2,800 revolutions per minute. I want the angular speed in radians per second. Okay, so my angular speed, omega, equals theta over t. Theta is the number of revolutions, 2,800 times 2 pi, that's radians, over 1, what is the time that I'm starting with? Minutes, okay, because it's within the revolution, so that means this is for 1 minute. I need it in radians per second, so I need to convert. Could I multiply 2 times 2,800? Sure, but I may just be having to divide it back by 2, so I'm not even going to do that. If it's like small numbers, maybe I'll do it just because whatever, but I'm just going to leave it like that right now and go ahead and put in my conversions here. I want radians, so I'm good with the radians, but I want radians per second, so this would be minutes up here so that it'll cancel out, seconds down there. For every 1 minute, there is 60 seconds. So now I have radians per second, and I can simplify. I can divide these both by 10, knock out the zeros. This 2 can go away, and I can make this 3. Is 280 divisible by 3? No, because 2 plus 8 is 10. So I now have that my angular speed is 280 pi over 3 radians per second. Okay. Go ahead. Yeah. Okay. I was trying to, where are you going with this? Okay. So this 280, I would add 2 and 8, that gives me 10. Now that number itself doesn't mean anything for the division, but whatever number you get, if that is divisible by 3, then the number is divisible by 3. So like for instance, if I have 144, when I add those up, those add up, this gives me 4, that's 8, and 9, so this gives me 9. So that tells me not only is 144 divisible by 3, because this number is divisible by 3, it's also divisible by 9, because this number is divisible by 9. Yeah. So that way there's no guessing and checking there. You know what I mean? You can look at it and know. Yeah. Yeah, and that's fine. I mean, and you can do that, and that's great too that you're at least doing that. But that kind of saves you like, oh, I can't even do it. I don't even have to do that much. Okay, it's a quick little add. Yeah. I know it bothers me a lot that y'all get to this point in your math careers and you don't know that. I feel like that's such an important skill. Yeah. I feel like you should have known that for a long time. It helps with a lot, right? All right, anything else? It's a very good question. All right, let's look at number 5. A windmill has blades that are 14 feet long. So is that the radius or the diameter? The radius. Okay, if the windmill's rotating at 5 revolutions per second, I want the linear speed in miles per hour. Okay, so I'm going to have to start off with the arc length. Arc length is r theta. So that's 14 times the number of revolutions, which is 5, times 2 pi. Now with these numbers, I'd probably go ahead and multiply this because it's smaller numbers. So 2 times 5 is 10, times 14 is 140 pi, and that would be feet. If you want to leave them split up, that's fine too. You just kind of do whatever you feel like you need to do at that time. All right, so then your velocity is s over t. So that's 140 pi feet over 1 what? Second. Very good. Okay. Now I'm going to give you some time. I want you to convert that. And I want you to do it without looking at mine while I do it. whenever you are ready to look at mine, finish yours first. If we didn't reduce in the exact same way, it's fine. As long as we got the same answer in the end, you have to do whatever makes sense to you along the way. The other question that I usually get is, if I know that there's 3,600 seconds in an hour, can I just directly convert that way? Sure, that's fine. I don't care how you do it. But it would be simpler, in my opinion, but it's my opinion, if those two 60s were split, because you're trying to break it down anyway. So the more broken down it is when you start, the easier it's going to be to knock things out. Okay. And I went back and like circled the numbers I was using, so I made sure I didn't lose anything in my work or forget that something was there. Does anybody have any questions for me? I hope I gave you enough time to finish that. Okay, so there's more than one linear velocity formula. So I was debating on which one to focus on, and honestly I kind of change that every year, but I went back and it doesn't matter which one you use, you're going to get the same answer. But and I don't teach physics, so I'm not sure, and I think I've asked before, but I didn't really get a clear answer. But I feel like when you see the formulas together, you usually see linear speed and angular speed like together, and you usually see the two that we started with. Okay, so this one you may see as well, but I don't feel like it's that prevalent. But again, I just want you to know there's something else out there. So let's think about what we do know. We know the linear speed formula. So we know that velocity is equal to s over t. All right. And we know that s is arc length, so that could be r theta over t. So I just substituted that in. Just substituted in r theta. I'm going to take that fraction and just write it in a different form so that it looks like this. That's the same as the one before, right? And then tell me, what does theta over t represent that we just talked about today? Angular speed, exactly. This is your angular speed formula. That is omega. So this really could just be r omega. So your two options for velocity. Velocity equals arc length over time. That's what we were just using. You can also say that velocity equals r omega, radius times angular speed. Either one of them works. It kind of depends on the situation that you're in. You have to find the same information no matter what. It's just like the order you find it in. Or maybe you already know the angular speed. If you know the angular speed, you can just multiply it by the radius. Boom, there's your velocity. And that way you don't have to change it to arc length and all that good kind of stuff. So either way, we're going to work this question with the r omega formula. But when you actually go to do these, whichever one you want to use, I don't care as long as you're doing them correctly and it makes sense to you. Okay? Doesn't matter to me. All right, so Ryan is riding a bicycle whose wheels are 28 inches in diameter. That means R equals 14. If the wheels rotate at 130 RPM, I want the linear speed in miles per hour. Okay, so since I'm going to use velocity equals R omega, I'm going to need to find omega. So this is theta over t. Theta is the number of revolutions, 130 times 2 pi. That'll give me radians up there, over 1 what? Minute, because RPMs, revolutions per minute. Now, I could multiply that and make it 260, but I have a feeling I'll need to cancel a 2 out of the denominator somehow, so I might as well just leave it like that so that there's less to do. So I will put that into my velocity formula. Velocity is the radius, which is 14 inches. And since that's a whole number, I'm going to put it over 1 because I know I'm going to have a whole bunch of fractions here, times omega, which is 130 times 2 pi over 1 minute. Now I want you to look at that and notice that when I substituted that in, I dropped the radians off. Like, our units are super important here and that we don't drop them off, but I dropped the radians off because there's not anything that's going to cancel that out. So here's the deal with angle measures. The degrees and radians, angles are actually a unitless value. We use degrees and radians and we call them units, and they are units, but they're really just placeholders that imply rotation. So as far as the inches and minutes and whatever goes, yes, we talk about it like this is radians per minute, but once we substitute it into something else, I'm not going to keep the radians there and then like cancel them out. Okay, so it's kind of a strange concept, I know, but I'm not dropping it off. It's not like it's allowed there. It's just implying rotation. So when you substitute it in to something, you usually don't keep that there. All right, so that's why it's just gone. And we have this, my velocity would be in inches per minute at this point, but I want it in miles per hour. So we're just going to do this one together too, just for the interest of time. So I'm going to multiply, since I want it in, I can't see that now, miles per hour. I'm going to take my inches and I'm going to change that to feet. So inches down here, feet up here, 12 inches, 1 foot. Inches cancel out. Then feet down here, miles up here, 5,280 feet, 1 mile. Feet, feet. So I have my miles. I'm in minutes. I need it into hours, so minutes go up here, so they will cancel out. Hours down here, 60 minutes, 1 hour. So now I have my miles per hour, and I can start to reduce. Okay, so we'll start with the 12. Okay, so I can cancel the 12 and the 14. That can be 6 and 7. This 6, I can cancel out this 2 and make this into 3. Now 130 is not divisible by 3, but 60 is, so I can make this into 20 and get rid of that 3 right there. So now in the denominator, all I have left is 5,280. And so I can divide by 10. I can knock this 0 out with this one or the other one. It doesn't matter. Okay. Then I have 7 and 13. I'm pretty sure neither one of them divide into 528, but I'm not going to stress out about that because I got this 20. And I know that I can divide that by 2 and get 10 here and 264 here. And then I can divide it in 2 again, and I can get 5 and 132. So now the only number I have left in the denominator is 132. 5, I can't reduce with the 5. 13 doesn't go in there, and neither does 7. So the numbers I'm left with are these. Okay. So I'm going to have 7 times 13 times 5 over 132. So if I multiply this 7 times 13, 7 times 10 is 30. No, it's not. I don't know where that came from. 7 times 10 is 70. And then 7 times 3 is 21. So together these give me 91. So let me give you a little trick to multiplying by 5 if you haven't already thought. Not multiplying by 5 is probably easier than multiplying by a lot of things. But if I multiply by 5, I can actually multiply by 10, which is super easy, and then divide by 2. So if I multiply this by 10, I get 910, divide that in half. Half of 900 is 450, and then another 5. So I would get 455 pi over 132. And that would be miles per hour. And if you know that it was reduced as much as you possibly can before you multiply things back together, then you can't reduce this anymore. And it's much easier when it's split up to see whether or not you can reduce than when it's all in one piece. Okay? Any questions at all? Practice, practice, practice that number sense. I'm telling you, you will be glad that you did. It's going to make a lot of things easier that you don't even realize. Check yourself, that's fine. But I want to see the work. I want to see that you're actually trying to think through these things on your own. And again, if you would have thought through if you would have canceled out different numbers, like on the front, I did the 12 and the 60 to make that 1 and 5. I could have started that way. It doesn't matter. Whatever makes the most sense to you. Okay? Any questions at all? All right, so your assignment is in CAMI. Don't forget that.